This is Mrs. Hassler's video for your unit review on geometry. So again, don't forget that you have a test tomorrow. You completed your review sheet in 2 days. So you have last Friday's assignment on similar triangles and everything you need to know there. And then today we did our review on our basic translation. So we got translations, dilations, reflections, and rotations. Also, again, your similar triangles. Please do not forget about that. They are going to be on the test, plain and simple. Look over your review sheet from Friday. All right, so let's get started. Please remember that the best part about this video is that you do not have to watch the whole thing. Fast forward, rewind, stop me, do whatever you need to do to make sure that you understand everything on your review sheet, and that if you have any questions, you can ask me specifically when you see me tomorrow. So I'm just going to go through the worksheet just like we did in class so that you've got me here if you're practicing on your own and doing any studying. So whenever you have two fractions set equal, you know that you're going to cross multiply. The really important thing here is that you've got a binomial there, so you have to use your distribution. Times 15x, commutative property, doesn't matter which order. You get 5x plus 40 equals 15x. Don't forget about your rainbow math, your superhero. However you remember it is fine by me. 15x is bigger, so we're going to put variables and constants on the left. 5x is not a constant, so subtract it over. Please remember there is a positive there. You put it there if you need it. Don't worry about it if you don't. 15x minus 5x are like terms. You get 10x. The 10 and the x are connected by multiplication. You break it by division, and you get x equals 4. This can then be checked in. Every time you see an x, you plug in a 4. You can plug in, substitute, and then check. Make sure you get the right answer. Coming over here, same thing. All right, you don't have to worry about 30 times x. That's just monomial times monomial. You got to be careful when you take your 10 and multiply it by 12 minus x. There is a coefficient of 1 in front of the x. You know that. If you need it there, you put it there. You do as much or as little as you need to get it right. You get 30x equals 10 times 12 is 120. 10 times negative 1 is negative 10. The x tags along. Again, variables on both sides. 30 is bigger than the negative 10, so constants only. Negative 10 gets kicked out by adding 10. They're like terms. 40x equals 120. They're connected by multiplication, so you do division. And you get x equals 3. This one looks intimidating because you have binomials in both numerators, but because you're cross multiplying, you don't have to ever multiply the two binomials together. Do not be thinking top times top or bottom times bottom. You are not multiplying fractions here. They are set equal. So you get 5 times 3x plus 3 has to equal 3 times 7x minus 1. Cross multiplying. Some of you are still doing that. That is fine if that's the approach that works for you. This is multiplication. You're multiplying one term by two terms. A monomial times a binomial. You get 15x plus 15 equals 3 times 7 is 21x. 3 times negative 1 is negative 3. Variables on both sides. So I'm going to bring my variables on the right and my constants on the left because 21x is larger than 15x. Constants only, that 15 has got to go. It is positive 15, but the positive is assumed. So we're going to subtract the 15x over. 15 equals 6x minus 3. Variables only. The negative 3 has got to go. So we add the 3 over. 18 equals 6x. Divide by 6. And you get x equals 3. And then last but not least for this one, again, you've got a binomial over a binomial. Looks kind of strange, but because we're cross multiplying, it's just the same old, guys. Do not be intimidated by what it looks like. You can put the 1 out in front if you need to, but remember that 1 is your multiplicative identity. Anything times 1 stays that number. But better safe than sorry. You do get negative 9. Most of you are very good at your integers at this point. Really doing a nice job. So I've got 3x on the left and x on the right, so I'm going to do my variables on the left. I got to add my constant over. I don't need him. Equals x plus 16. Remember that this is a positive 1x. You put it there if you need it. You move it by subtracting 1x. And you get 2x equals 16, divide by 2, and x equals 8. So if you have any questions on how to go about your proportions, all right, two fractions set equal, make sure you come in and see me and tell me that specifically. I need help on questions 1 through 4. Moving on to the word problem type questions, the scale and a roadmap is shown below. They're giving you your fact. Without a doubt, you know that 1 centimeter is equal to 75 miles in this case. They're telling you that Sam measures the distance on a map and got 5 centimeters. What is the actual distance in miles? We set it up as fact and find. We know without a doubt that 1 centimeter is the same as 75 miles. Be careful when you set up your proportions. They need to be corresponding. So the 5 represents centimeters. You're going to put that up in the numerator because that's where I have my 1. And x is in the bottom. Now you just have a very basic proportion. It's a lot easier because you had to set it up on your own. And you get 1x equals 5 times 75. 1x equals 375. And everybody's different. You don't need that 1 there, but if it helps you to make sure you complete your process, you're going to get x equals 375. Do not forget to label miles, and you're all set. The next one is very similar, except it's up to you if you want to draw any type of picture or anything like that. Completely up to you. Do as much or as little as you need. They're giving you your scale. They're giving you your ratio. 1 centimeter is equal to 0.5 kilometers. The map distance of blank corresponds to the actual distance of 12 kilometers. So again, your fact is 1 centimeter is to 0.5. I'm going to convert 0.5 into a half. I would much rather work with fractions, but it's up to you. 12 kilometers. We don't know the centimeters, so whenever we don't know something in math, that's our variable, and our 12 is on the bottom. When you cross multiply, you get 12 equals 1/2 x. Whenever you have a fractional coefficient, you're just going to multiply by the reciprocal. 2 times 12 is 24 over 1, so we're just going to put 24x. So our answer is, what is the actual distance of 12 kilometers? Well, the corresponding to 12 kilometers would be 24 centimeters. 7 is what I was talking about with the picture. You're talking about a height of a tree to a shadow, and then a height of a flagpole to a shadow. Very easy to draw a picture, not that big of a deal. All right, you can draw a tree in just a matter of seconds with a height of 14. That casts a shadow of 8. Again, just draw your shadow. It doesn't have to be anything, too pretty or anything like that. At the same time, a nearby flagpole casts a shadow that is 10. You do not know the height of the flagpole. That's why I really like to draw pictures. It helps break down a word problem. Lots of ways to set this proportion up. 14 is to x, as 8 is to 10, I think would be the most popular way to set it up. But depending on how you did it, as long as your cross products are the same as mine, you set it up correctly. You get 8x equals 14 times 10. 8x equals 140. Divide by 8, and you do get 17.5. Write the statement of proportionality and find x, then state the scale factor. These are kind of hard because what I've done is I've either rotated or translated, I flipped around, I did all sorts of things. They're definitely similar to each other. We know that because of that symbol right there means similar. But you have to be able to identify without a doubt your corresponding sides and angles. And that's why they gave you this right here. That tells you without a doubt, because the letters represent angles and they represent what angles correspond to what angles. What I mean by that is A is mentioned first. So A corresponds to D. B corresponds to E. And C corresponds to F. They follow in order. Your statement of proportionality is the proportion of setting your corresponding side lengths equal to each other. Remember that no matter what the numbers are, they all need to simplify down to the same scale factor. So what your statement of proportionality is, you can start wherever you want, but be very careful when you're labeling. If I'm going to compare AB, That's the 1 to the 2. You got to start with 1 and compare it to the 2. So AB corresponds to DE. AC corresponds to DF. And BC corresponds to EF. There's my statement of proportionality. You then use your statement of proportionality to find your scale factor and to solve for x. 5 is to 8 as 6 is to x. Now you just cross multiply and solve. You get 5x equals 8 times 6 is 48. Divide by 5, and you get x equals 9.6. Well, what's my scale factor? It's all connected. Your scale factor is right here. It's the 5/8. When you plug in 9.6, you've got to get your answer to simplify down, and everything will always simplify down to your 5/8. You'll get the exact same proportion. This one here, even harder to tell what angle corresponds to what angle and what side corresponds to what side. So you've got to pay attention to this right here. This is my proof that my triangles are similar. You can't just assume it. They're telling you that S corresponds to B, U corresponds to E, and N corresponds to D. So what happened is that I rotated it up counterclockwise. This one, you know, angle N was down at the bottom and now it's up at the top. I just rotated it up. And now we're going to talk about our statement of proportionality. What sides correspond to what sides? So SU, 1 to 2, is 1 to 2, is BE. SN to BD. And UN to ED. There's my statement of proportionality. Without a doubt, they all have to reduce to the exact same fraction or else they're not proportionate and they're not similar. I use my statement of proportionality to then find x. I know that 8 is to 32 as 12 is to x. Cross multiply. 8x equals 12 times 32. I'm going to write that one down because I got to think about that one for a second. 12 times 32, you can write it over on the side, gives you 384. Divide by 8, and you get 48. So the length of x needs to be 48 in order for these triangles to be similar. And then your scale factor would just be your 8 over 32, which I can then reduce by 8, and my scale factor is 1/4. So most of us are really good with our proportions and all that work. This is the stuff that we were struggling on. This is the stuff that I can't necessarily help you with, guys, other than to give you ways of remembering things. I recommended that you make flashcards. It's one of the best ways to help you with memorization. Incredibly important. Make sure you know your rules. Do not come to class tomorrow without knowing your rules. When you reflect over the y-axis, you're counting to the y and counting away from the y. All you have to remember to do is change the sign on the x. When you reflect over the x, counting to the x-axis and counting away, you change the sign on the y. Remember, that does not mean make it negative. That negative in your standard form means change the sign. Your reflection of 180, negative x, negative y. This T stands for translation, or picking your shape up and moving it around. You're going to take whatever your coordinate is, whatever your xy is, and then this tells you what you're adding or subtracting. You're going to add a to x and b to y. D stands for dilation, making something bigger or smaller, the only operation that ends up changing the size of the shape. Remember that dilation is multiplication. So you take whatever your xy is, no matter what it is, and you just multiply both the numbers by whatever your scale factor is. Rotating 90, switch and negate. Switch, negate the front. 270, switch, and negate the back. Again, negatives do not mean make it negative. That negative means change the sign. So when you use your basic standard form rules, you can apply it to whatever I give you. If I just give you a coordinate like I do here, if I give you an entire shape, a line segment, an angle, no matter what it is, if you know your rules, you can apply it to anything. So all we're looking at is one coordinate, the coordinate 4, -3, which is in quadrant number 4. There's no need to be drawing over here your X and Y axis and trying to make graph paper for yourself. If you know your rules, your life is pretty easy, guys. When you reflect over the X, you change the sign on the Y. So my coordinate was 4, -3, but I have to change the Y, so now it's positive. I just get 4, 3. When I reflect over the Y, I change the X. So it was 4, -3, but I changed the sign on the X and get -4, -3. If I do a reflection over the origin, that's the exact same as a rotation of 180, which means I change both my signs. Maybe you want to, hold on, maybe you want to write the rule up here. You're going to get X -Y, -XY. Origin is -X, -Y, so you get -4, 3. If you have any questions, let me know. Make your flashcards and study. Flip it over. We're doing the same thing. We're still using these rules. There's no graph paper here for you. We're not counting or anything like that. There's our coordinate, -3, 6. If we reflect it over the y-axis, you're changing the x. So it's not -3, 6 anymore. It's +3, 6. Reflecting the x-axis, change the y. Leave the x alone and negate the y, meaning it was positive, so now it's negative. Capital T, translate, picking it up and moving it. -4 means left 4, up 7, except you don't have graph paper, but that's no big deal. You're going to take your coordinate, which is -3, 6. What are you going to do to it? Well, -4 comes first. You're subtracting 4. +7 comes second. You're adding 7. Careful with your signs. They're on the same team, so they're going to stay on the negatives. Add them up to get -7. And then 6 + 7 is 13. You could, of course, then go flip to graph paper and check it, but make sure you understand what I'm doing. A translation is picking it up. I picked my coordinate up. I moved it farther into the negatives by 4. That's why I end up with a bigger negative number. And then I moved it up by 7. I was already in the positives all the way up at 6. If you add 7 to me, I'm all the way up to +13. D3, dilation of 3, meaning multiply every number you see by 3. So I'm going to do this one in my head. -3 times 3, -9. 6 times 3, 18. Rotation of 90, I'm going to write that rule down. That's my flip and negate the front. So I'm going to do my flip first. I had -3, 6, so now I have 6, -3, and I'm going to change the sign on the front. So now I have -6, -3. 180, that's -X, -Y. I did have -3, 6, so now I have +3, -6. That's all it is, guys. Please don't say to yourself, well, look, the 3 is already negative, so it stays negative. Absolutely not. The negative on a standard form rule says change the sign, not make it negative. Multiply by the -1, which changes your sign. All right, so now we're going to do kind of the opposite of what we were doing. Instead of me giving you a rule and then change the coordinate, I already changed the coordinate for you, and I'd like you to figure out the rule. So if I started at 3, 5 and ended up all the way over at -5, 7, I want to know what happened. Well, capital T for translate. If you're at +3 and you're going to go to -5, what you have to do is subtract 8. If I'm at 5 and I end up at 7, I had to add 2. A good check for this is if I have 3 and I subtract 8, negatives win by 5. You should be able to use your rule to go from the original coordinate to the image. -4 to -6, that one's a little bit easier. All I did is subtract 2. I went further into the negatives by 2. But then this one's the more challenging. I'm up at 6 and I have to go down to -8. Well, if you're at positive 6 and you want to get to 0, that's 6 places. And now I'm at 0 and I want to go down to negative 8. Okay, so that's another 8 spaces. 6 plus 8 is 14. You had to subtract 14 from positive 6 to get to negative 8. Then if you use A and you use your rule, you'll get to your image. Dilation, I went from 3 to 9. You have to remember that dilation is a rule of multiplication. Best way to figure out what your scale factor is you put the new value over the original and reduce. 9/3 is the same as 3. We dilated by 3. Let's check it out. 3 times 3 is 9. 5 times 3 is 15. Perfect. Same thing here. Dilation. I went from 6 to negative 2. So I'm going to put my negative 2 over 6. I'm going to reduce by 2. And I get negative 1/3. I did a dilation of negative 1/3. When we check it out, 6 times negative 1/3 is negative 2. Negative 9 times negative 1/3, negative times the negative is a positive. 9 divided by 3 is 3. We talked about this briefly in class. Remember the dilations. If you dilate by a number greater than 1, it gets bigger. And if we multiply by a fraction, it's going to get smaller. If you're a little bit confused by that, please reference the videos on dilations, and it'll help you kind of jog your memory and remember how to do that. All right, now this is just another way of talking about your translation. All right, instead of it being a rule of negative 8, 6, which is be the exact same thing as this right here, I just have it in a different notation. I want to know what the coordinate of A prime, the image of this point under the translation, is. Now you can show your work or you can do it in your head, but every coordinate is made up of an X and a Y. Every time I see an X, I plug in a 10. You're basically just going to plug it right in. There's your 10. 2 is for Y. And now just be careful with your integers. 10 minus 8 is 2, and 2 plus 6 is 8. That would be your value of A prime. You're going to go left 8, and then you're going to go up 6. But this right here is your answer. That's all you really need. But it's all connected, guys. It's all the same thing over and over again. What is the image of 2, 1 under dilation of 5? Dilation just means multiply. Multiply every number you see. So 2 times 5 is 10. 1 times 5 is 5. There's your new image. Done. What is the image of negative 8, 7 after rotation of 90 degrees counterclockwise about the origin? Remember that counterclockwise is a good thing. Counterclockwise is the rules that you know. You only have to be really careful if I tell you to rotate clockwise. 90 degrees counterclockwise. Switch and negate. If you know your rule, life is good. Very simple. I have a tendency to switch my X and Y first. That's what I do. So negative 8 is in the back, 7 is in the front. My rule says change the sign on the front number, but leave the second number alone. So that's now negative 7, negative 8. If you know your rules, it's pretty simple. Now we're going to go over the graphing questions on the back. Most of you are very good at graphing. Please remember to walk before you climb or fall. So when I graph my originals, I'm always going to start at my origin. I'm going to go over to up 1 and label. Don't forget to label. I am going to take off points for that. It's very, very, very important. And then C is walk to 2, climb to 5. There we go right there. There's my little triangle. And now I'm set to see what I have to do. What do I have to do? On the same set of axes, graph and state. Triangle A prime, B prime, C prime, the image of triangle ABC under a rotation of 90 degrees counterclockwise about the origin. So now, instead of just working with our coordinates, we're going to then graph them. The good thing about it is it's the same rule. You don't need a new rule for this. It's switching and negating the front. Please write everything out nice, neat, and organized. You will be far less likely to make a mistake. So ready? I'm taking my original coordinate 2, 1. I'm going to flip it first so I don't get confused, and then change the sign on the front. 4, 2. Change the order, flip the sign on the front. 2, 5. Change the order, and then change the sign on the front. It's that simple, guys. Here's your coordinates right there for all your primes. So now I'm going to walk to -1, climb to 2, A prime. Walk to -2, climb to 4, B prime. Walk to -5, climb up to 2, C prime. Notice that the shape didn't change. It's completely congruent. It is copy, pasted, and then just turned. If something changed about it, the size of it, the angles, then something went wrong. You've got to get something that's congruent, equal, the exact same thing. Now be careful with the wording of C. On the set of axes, graph and state A double prime, B double prime, and C double prime, the image of A, B, C under a dilation of 2. Well, which coordinates am I going to use? Because now you have 2 sets of coordinates. This is telling you right here that triangle ABC is your starting point. So you're going to rewrite your coordinates. You don't want to make a mistake. It's going to be so easy, guys, to grab the wrong coordinates, and I don't want that to happen to you. So please be careful. Be neat and organized. I'm not going to give you a table so that you have all the empty space that you need. Just please be careful. So if I'm going to do a dilation of 2, that means that I'm going to take every single number that I see and I'm going to multiply it by the number 2 because that's my scale factor. So I'm going to get 4, 2, 8, 4, and 4, 10. When I come over here and graph it, I'm just going to be very careful. So I go 1, 2, 3, 4, 1, 2. That's overlapping. It's okay that that happens, but be careful. You got to replot your point, and you need to label it with A double prime. 8, 4 is B double prime, and then C double prime. Remember that a dilation is what makes similar figures copy pasted and then the corner is dragged out or dragged in, but it still needs to have the same basic shape. We know that the corresponding angles have to be the exact same thing, and the only thing that's different is that the side lengths are in proportion. I multiplied everything by 2. I didn't multiply some by 2 and others by 3 and make a different shape. When I dragged out that corner, I just made it bigger by 2. So this should be your final result. You need everything labeled. All right, we cannot have any messiness going on, and you need to use a straight edge. Last but not least, for most of us, this is the question that we did not get to in class. So make sure you're paying close attention. We're going to start off just by graphing. That's my L, 2, 3, 1, 1, and 6, 1. Always remembering to walk before we climb or fall. I know you're kind of sick of me saying that, but it's very easy to forget, and then you end up with the wrong original shape, and it's going to throw everything off. So here we go. Let's look what we got to do. All right, I did this, so maybe you want to put a little check mark to it. I draw and I labeled my original. Good, done. Graph and state the coordinates of my primes after a rotation of 180. Okay, so a rotation of 180 is 2 turns, and the way you do it is you change the sign on both. You don't change the order. Order changes stays exactly the same. So I'm going to make a little note to myself. I'm doing a 180-degree rotation. Here's my rule, and I'm just going to start working. I like to stay nice and organized. I think it's important. I would like to see the same from you. And here we go. We don't change the order at all. It stays exactly the same. These negatives mean change the sign. So this is now a -2, and that's a -3. 1, 1, but is now -1, -1. And then it was 6, 1, but now it's -6, -1. There's your rotation. It's done, just like that. But you have to know your rules. You have to know them. So I'm going to walk to -2, fall to -3, L prime. Walk to -1, fall to -1, M prime. Walk to -6, fall to -1, N prime. And just like that, I have a completely congruent triangle that has been rotated 180 degrees. 90 would be over here, 180 would fall down to quadrant 3. There's my answer, completely congruent, and everything looks okay. Hopefully I didn't make an oops. Now, it says graph and state the coordinates of double prime, the image of. This is telling me which set of coordinates to follow. See these little dashes up here? These are your primes. After a reflection over the line y equals 2, meaning that these coordinates do not mean anything to me right now. All right, you can keep them. You can just write your work down here, but I'm just going to erase them quick so that I can keep everything on the screen. So you're going to leave yours. I'm just going to erase mine because now I'm going to do this. I'm going to reflect over the line y equals 2. So I've got to change my I'll just erase everything. It's kind of messy. All right. So give me a second. I got to erase. Okay. So I'm erasing my originals because that's what I don't need anymore. I'm going to use the coordinates of my primes. Oh, goodness. Should have just erased it. All right, here we go. Sorry about that. All right. So we have M prime was at -1, -1. L prime was at -2, -3. And N prime was at -6, -1. All right, so it's okay if you have a different order. It'll all be the same thing. The problem is that we have to reflect over the line y equals 2. So this is our reflection line. This does not mean the y-axis. It would have to say reflect over the y-axis. Standard form of a linear equation is y equals mx plus b. Okay. Well, this just says y equals 2. Why is that? Oh, because there was a 0 slope. Your slope is 0, and your y-intercept is 2. I mean, guys, don't overcomplicate it. It literally means that you go to the y-axis, you find 2. Well, here is my 0 slope. Like the slope man with his face, his mouth was a 0. Straight horizontal line. This is the line y equals 2. Now, how do I reflect the primes over this line? Remember that it says to go to the primes. You put your pen on the prime, literally. Count to the line. So 1, 2, 3, 1, 2, 3. M double prime. Put your pen on L. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's L double prime. And then N, 1, 2, 3, 1, 2, 3. There's your reflection. Remember that a reflection is a flip. It means that if you were to fold your paper on that dotted line, and this was in paint, you should get this exact image. A reflection is a flip. You flipped it over. So now that that's all set, we've only got one thing left to do. What are we going to do? We're going to graph and state the coordinates of L triple prime, M triple prime, N triple prime, the image of my doubles. So okay, that's why it's so important to label. So we're going to move this guy right here. After a translation which maps 6, -9. Translation means pick it up, move it around. How am I going to do a translation of 6, -9? Well, you're going to go right 6 and then down 9. Or you can do the math once you write your coordinates down. So you put your pen on your double prime. That's what we're moving. Put your pen on L double prime. Count over 6. 1, 2, 3, 4, 5, 6. Down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, very important why you need to be neat. M double prime. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. M triple prime. Put your pen on N. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's your n triple prime, and we are all done. You get a congruent triangle. None of these triangles are at all different. They're just in different positions. They're all congruent. The corresponding angles are the same. The corresponding side lengths are the same. You have not changed them because you did not complete a dilation. They're all rigid transformations. You're set. You're done. And the last thing to do, technically, I said to state the coordinates. All right. You should have your coordinates of L triple prime. You're going to walk to 4, fall to -2. M triple prime, you walked to 5 and fell to -4. And then N triple prime, you didn't walk left or right at all, and then you fell 1, 2, 3, 4 to -4. And then you'd be all set, guys. This is why it's so important to be nice, neat, and organized. This would be a great question for the test because it requires you to know how to rotate, how to translate, or how to reflect and how to translate. You know, it's 3 great questions all in one. Please feel free to ask me any questions that you need to and direct me specifically to this question if you are at all confused, or send me an email and I'd love to answer your question. The last thing I want to talk about before I let you go is to please remember to look over your Friday's review sheet. All right, look it over. The directions in this question were to solve for x. All right, x being right here. Remember that these were your similar triangles. They were overlapping. All right, so you've got your giant triangle here, which is A, B, C. And then you've got your smaller triangle here, which is A, E, F. You don't know the length, but that's why they gave you the coordinates. If you start at 2 and you're up at 11, that's a length of 9. If you're starting at 0 and you walk to 6, this is a length of 6. You can do the same thing here with this triangle. If you started at 2 but only went up to 8, that's a length of 6. You have no idea the length of EF because that's the value you're looking for in the first place. And now you just have similar triangles. 9 is to 6 as 6 is to x. Cross multiply, 9x equals 6 times 6. 9x equals 36. Divide by 9, and you get 4. If you have any questions, please come and see me. Do not wait till you're walking in the door. I'd love to answer any of your questions. Come and see me probably before school, or if you're 8th period, come see me during study hall or lunch. Hope this helped, and send me an email, guys, if you need to. I'll see you tomorrow. Good luck.